Okay, so let's jump in. Imagine you're a dev, right? You're building this complex, deep, maybe doing everything, smart contracts, data, UI, the whole stack in one go.
Yeah, a familiar picture for many developers.
Now think about breaking that down. Specialized services, each doing one thing really, really well. That's kind of the idea behind what we're exploring today with Ethereum, proposer-builder separation, or PBS.
Exactly. It's basically introducing specialization into how Ethereum blocks get made. It's a big shift.
So instead of one person or one validator doing everything.
Right. You split the roles, you have block proposers. These are still the validators we know, but their main job changes. It becomes about choosing the best block that's already been built.
And then you have the other side.
The block builders. These are specialists. Their whole focus is putting together the contents of the block, ordering the transactions, grabbing any MEV, making it all efficient.
Got it. So for a developer listening, someone who gets the EVM understands transaction ordering. This isn't just like some abstract theory.
Not at all. PBS has real consequences for, network speed, whether your transaction gets included, and even how Ethereum scales up in the future.
And it sounds like this is actually happening, not just whiteboard stuff.
Oh, yeah. There's serious work being done to bring this onto the main network. It's moving forward.
Okay, let's maybe rewind a bit first. What did it look like before PBS? The old way.
So traditionally, Ethereum validators had to do both jobs. They proposed the new block, and they built it. They decided which transactions went in and in what order.
It was all bundled together.
Tightly coupled, yeah.
And this is where MEV comes into play, right?
Yeah.
Maximal extractable value.
For a dev, how should we think about that?
Think of it as extra profit a validator could make just by cleverly arranging the transactions in the block they were building.
Like spotting a big trade on Uniswap and jumping in front.
That's a classic example,
Yep.
yeah. Arbitrage opportunities. If a validator saw a chance based on the pending transactions, they could insert their own to capture that value. But doing that effectively, it's not simple, right? You need special software, you need to be quick.
Exactly. It requires pretty sophisticated tech and market smarts. And this is where you started seeing potential centralization issues. Validators who were good at MEV could earn more, attract more stake.
Kind of pushing out the smaller, maybe solo stakers.
Potentially, yes. It created an uneven playing field based on technical sophistication.
And then these searchers popped up.
Right. Specialized actors just hunting for MEV opportunities. They weren't usually validators themselves. They'd find an opportunity, bundle up the transactions needed to capture it.
An atomic bundle, meaning they all had to execute together in order.
Precisely. And then they'd send this bundle off to a block producer hoping they'd include it.
But there's a trust issue there, isn't there?
A huge one. The searcher had to trust the producer not to just, steal their strategy or front run them.
Like that big sandwich attack someone mentioned. $25 million. Ouch.
Yeah, that was a stark example of what happens when that trust breaks down, when the atomicity wasn't guaranteed by the system itself.
Okay, so the old system had issues. Complexity, centralization risk, trust problems. How does PBS try to fix this?
The core idea is simple, conceptually. Separate the job of building the block from proposing it. Decouple those responsibilities.
So builders build, proposers propose.
Pretty much. Builders compete. They put together the best block they can, the most valuable list of transactions, and then they basically bid for the right to have their block included.
They bid to the proposer.
Exactly. They submit a bid saying, hey, include my block and I'll pay you this much. The proposer looks at the bids and picks the highest one usually, or maybe one that follows certain rules they care about.
And the crucial part is this pre-confirmation privacy idea.
Yes, that's key. The proposer chooses the winning bid without seeing the full list of transactions inside the block yet.
Ah, okay. So the proposer can't just look inside, find the MEV strategy, and steal it before confirming.
Correct. That information asymmetry is removed, at least from the proposer's perspective at the point of commitment. It protects the builder's work and the searcher's strategies indirectly. For a developer, it means more certainty that your clever transaction sequence won't get sniped by the validator overseeing things.
So validators don't need to be MEV geniuses anymore.
Nope. Their job shifts. It becomes more about evaluating these bids and selecting the best offer, rather than needing the complex infrastructure to find and extract MEV themselves.
Makes sense. Let's get into the nuts and bolts then. How does this bidding and selecting actually work? You mentioned an API call analogy.
Yeah, that's a good way to think about it. Builders send a request. Here's my block header. Here's my bid price. The proposer evaluates these requests and sends back a response by signing the header of the best one.
But how does this happen securely, especially now before it's fully baked into the protocol?
Right now, mostly through something called MEV Boost. And this relies on intermediaries called relays.
Relays. Okay, what do they do?
They act as trusted go-betweens. Builders send their complete blocks and their bids to a relay.
The full block goes to the relay.
Yes, the relay checks if the block is valid, if the bid matches up, all that stuff. Then, crucially, the relay only sends the block header and the bid amount to the proposer.
Okay, so the proposer sees, like, header A pays 1 ETH, header B pays 1.2 ETH.
Exactly. They pick the best one, say header B, sign that specific header, and send the signature back to the relay.
And only then does the relay reveal the full block B to the network.
Correct. Once it has the proposer's signed commitment to that header, it broadcasts the full block.
But wait, these relays, they're trusted third parties, right? Outside the main Ethereum protocol.
They are, and that's a concern. It introduces a potential point of centralization or censorship. What if a relay dominates the market? What if they decide to censor certain transactions or builders?
Yeah, I see the problem. Especially if one relay, like Flashbots, becomes the default for many.
Precisely. And that's the big driver behind moving towards in-protocol PBS or enshrined PBS.
Meaning building this proposer builder logic directly into Ethereum itself.
Exactly. Removing the need for those external trusted relays and making the separation of roles a core part of the protocol rules.
How would that work? I saw mention of a 2-slot design.
Yeah, that's one of the main proposals. The idea is to spread the process over 2 consecutive slots or time periods.
Okay, slot 1.
In the first slot, the proposer chooses the best bid they've received from builders and publishes a beacon block containing a commitment to that bid, basically pointing to the winning builder's block header.
So they commit publicly first. Then what?
Then, in the second slot, the builder whose bid was chosen reveals the actual execution block body, the list of transactions.
And the network needs to agree on both parts.
Yes, the network's consensus rules, the fork choice rules, would need to validate both the proposer's commitment block in slot 1 and the builder's execution block in slot 2. They're linked.
In this idea of binding bids, what's that about?
That's crucial for the in-protocol design. It means if a builder's bid is chosen by the proposer in slot 1, they have to pay the bid amount.
Even if they mess up and deliver a bad block, or no block at all in slot 2.
Yes. There's a mechanism to ensure they pay up. It creates a strong incentive for builders to only bid if they're confident they can deliver a valid block. It puts skin in the game.
Makes sense. Are there other ways they're thinking about doing in-protocol PBS?
Oh yeah, there are variations. Vitalik Buterin proposed using a tester's other validators to perform some relay-like functions within the protocol. There's active research into the best architecture.
Okay, so that's the mechanics. Let's zoom out again. What are the big wins here for Ethereum, especially thinking about developers and users?
A major one is lowering the bar for validators. Like we touched on, you don't need to be an MEV expert anymore.
Right, just pick the best bid.
Which makes running a validator more accessible, hopefully leading to more solo stakers, more decentralization at the consensus level.
And it helps equalize rewards too, right? Even if a few builders get really good at MEV.
The profit from that MEV gets passed on via the bid to whichever proposer picks their block. So it spreads the economic benefit more widely, preventing MEV skill from becoming this centralizing force where only the top validators earn big.
That seems like a big deal for decentralization. What about censorship?
PBS helps there too. Think about it. The builder might be pressured to censor transactions, maybe by regulation or something, but the proposer is economically driven to pick the highest bid.
And the highest bid usually comes from a block packed with valuable, non-censored transactions.
Generally, yes. Plus, you have mechanisms like inclusion lists.
Know those.
Basically, the proposer can say, okay, builder, I'll accept your high bid, but you must also include these specific transactions from my local view of the network, my mempool.
Ah, so the proposer can force inclusion of potentially censored transactions?
Exactly. It provides a direct tool to counteract builder-level censorship. There are also ideas about forcing builders to use all available block space, making it harder to selectively omit things.
So better decentralization, better censorship resistance. What else?
Well, just a generally more efficient and maybe fairer distribution of MEV. It turns MEV from this slightly shadowy validator game into an open auction market where the value flows back to proposers and thus stakers.
And you mentioned scalability earlier. How does PBS help with something like dank sharding?
Right. Danksharding involves handling much larger blocks, mainly filled with data from rollups, building these massive blocks efficiently, generating the necessary proofs. It's a complex task.
Probably too complex for the average validator to do on top of their regular duties.
Exactly. Having specialized, optimized builders who focus only on that block construction task is seen as pretty much essential for making danksharding practical. PBS provides that specialization.
Okay, the benefits seem pretty clear. But nothing's perfect. What are the downsides of the challenges developers should keep an eye on?
Well, the big one is builder centralization. While PBS helps decentralize proposing, the building market could still end up dominated by a few large, sophisticated players.
We're kind of seeing that already, right? With a few names popping up repeatedly as top builders.
We are. You see names like Beaverbuild, Titan, ARS. If only a handful of entities build most of the blocks, that creates its own centralization risks and potential choke points.
Makes sense. What else?
It just adds complexity to the protocol.
Yeah.
More moving parts, more coordination needed between these different actors.
Could that add delays? Latency?
It's a potential concern. The two-slot design, for example, inherently adds a bit of delay compared to the old way. Managing that coordination smoothly is important.
And getting the incentives right must be tricky.
Absolutely. You need to make sure builders are incentivized to build good blocks quickly, and proposers are incentivized to pick fairly and enforce things like inclusion lists. Designing those economic mechanisms is an ongoing process.
So lots of active research still on things like how inclusion lists should work best.
Definitely. And exploring other PBS designs, too, things called execution tickets, execution auctions, different ways to structure that bidding market.
And there's this balancing act, right, between making things simpler for validators versus keeping the protocol neutral and fair.
That's a core tension. How much responsibility do you take off the proposer without inadvertently giving too much power or introducing bias elsewhere, like with the builders or potential relay mechanisms?
But despite these challenges, the actual implementation work is moving ahead in clients like Prism, Lighthouse.
Yes. Based on the EIPs and specifications, the client teams are actively building this out. It's not just theoretical debate, code is being written.
So wrapping this up for the developer listening, PBS is really a fundamental change in Ethereum's architecture. Like we said at the start, moving from that single dev doing everything to specialized microservices.
Yeah, it's about creating specialized roles for better efficiency, resilience, and scalability down the line.
The main goals seem to be boosting decentralization, making censorship harder, and critically, enabling future upgrades like dank sharding.
That's the aim. Challenges remain, especially around builder concentration and complexity, but the push towards enshrining PBS in the protocol is a really significant evolution for the network.
So maybe a final thought for you, the developer. With this shift to PBS, how might it change the way you build apps? Does a more competitive, specialized block building market create new opportunities? Do you need to change your assumptions about how quickly transactions get confirmed or if they might face new kinds of ordering?
It's definitely worth digging into the details, the EIPs, the research posts. Understanding how block construction is changing could really impact how you design and deploy applications on Ethereum going forward. It's a space to watch closely.